So in this video, we'll analyze the barn and pole paradox that I described in the previous video. A quick reminder, the situation will start from Anna's point of view. So Anna's at rest. She's at rest with respect to a barn, and this barn has a width of 8 meters. So let's draw that barn on the space-time diagram. So we'll say it starts at 0, goes to 8. So that's the world line of the right side of the barn, and the world line of the left side of the barn coincides with the t-axis. So this is the barn. Beowulf is zipping along at a speed beta equals 3/5, and he has in his paws a stick, a pole that has a rest length of 10 meters. But Anastasia and us here at rest in the barn reference frame sees that length contracted to 8 meters. And so Anastasia will see that the barn and the pole coincide for just at a particular instant. And we're going to express that in terms of events. At this particular instant, the right end of the pole lining up with the right end of the barn, we're going to call that event F for front. And then this will be event B, the rear end of the pole aligning with the left end of the barn. So, and then the world line for the pole is going to be, well, in part, the world line of Beowulf, and we'll be moving at a speed of 3/5. So let me start by drawing the t prime axis and the x prime axis for Beowulf. So beta is 3/5 here, over 3 up 5. So that's my t prime axis. And then, let's see, over 5 up 3. This is going to be my x primed axis. And the stick, here's the one I want. I'm going to draw in this green. So the stick is moving also at a beta of 3/5. And let's see, over 3 up 5, over 3 up 5, yep. Okay. And I'm going to need to extend this axis 1, 2, 3, 1, 2, 3, 4, 5, something like that. All right, so that's the t prime axis. So this is event B, and this is event F. All right. So let's see what we can figure out from this diagram, and we'll do this both geometrically and with a little bit of algebra. All right, so this is the length of the barn in the unprimed frame, in the at-rest frame. Remember, when we measure length, those two position measurements have to be done simultaneously, and indeed, these are simultaneous in the unprimed frame. They both occur at t equals 0. What would the length of the barn be, and the barn is purple here, in Beowulf's frame, in the moving frame? So again, we would need to do simultaneous measurements. So these two events are not simultaneous in Beowulf's frame. But if I took a measurement here, and I'll call that event C, this will be event C, then these two measurements are simultaneous, and so we can subtract them to figure out the length. So we're going to have to calibrate the x prime axis. So let's think about that a little bit. First, beta here is 3/5, and that gives a Lorentz factor of 0.8. or a gamma of 1.25. So 3/5 is a particularly nice number to work with in special relativity. So let's use this to figure out what's going on here. What's the x prime coordinate, excuse me, for C? And remember that to calibrate an x primed axis, we use this approach. So this relates a spacing on the x-axis to a spacing on the x primed axis. And in this case, we know delta x. Delta x is 8. And we want to know what does that correspond to on the x primed axis. So let's see, I want to solve for delta x primed. I'll divide both sides by gamma. So I got delta x over gamma is delta x primed. And let's see, we've got, I'm going to use these numbers. So delta x is 8. That's the rest width of the barn. Gamma is 1.25. And let's see, 8 divided by 1.25 is 6.4. So that's what I mentioned in the previous video, that in Beowulf's frame, he'll see the length of the barn as being 6.4. So let's hold on to that fact for a second, and I'm going to now let me do a little more calibration of this x primed axis. So this here along the x primed axis, this is the length of the pole. And I know that this, right, because these are it's on either side of the object, and these two events are simultaneous according to Beowulf. And we've said that the rest length of the pole is 10. And so I know that this calibration is 10. And I could also see that if I drew a hyperbola. So if I had one of those calibration hyperbolas, it would look something like this. So what I'm saying is we know that this is 10. And so then I can use that fact to calibrate the rest of this. And let's see, I'm going to do that somewhat carefully with a ruler. So calibrating this, not super precisely, but I wanted this to be at least sort of to scale. We know that this is 10 because the rest length of the stick that Beowulf is carrying is 10. And so I just then divided this into 5 segments of 5 segments. And here's the 6 meter mark. And indeed, event C is a little bit more than 6. And that's exactly what we calculated using the special relativity formulas. And I should mention also, just so you sort of see how the math works, I had said that the rest length of Beowulf's pole, the one he's running with, is 10. But that gets contracted because he's moving with a speed of beta equals 3/5, and that gets contracted to 8. So that's how that math works out as well. All right, so now I have a sense of the length measurements. Let's think about time measurements. And in particular, let's focus on event F. And the thing to notice here is that event F is not simultaneous with event B. It is, okay, in Beowulf's frame. These events are simultaneous in Anna's frame. She sees the front and the back of the stick lining up with the front and back of the barn at a particular instant in time. But for Beowulf, he's going to see something very different. F is going to occur well before B. And to see that, let's figure out the t prime coordinate for event F. Remember, we do that by going parallel to the x primed axis. And if I do that with any luck, I'll get a negative number. So what I'll see is that F happens before B. So Beowulf sees that the front of the of his pole aligns with the front of the barn well before the rear of the pole aligns with the rear of the barn. So events B and F are not simultaneous at all. So I argued that this diagram shows us that in the moving frame, in the primed Beowulf frame, event F occurs before event B. What I want to do now is figure out the space-time coordinates of event F in the primed frame. And I'm going to do that two ways. First, let's use our friend the Lorentz transformation. So I know the coordinates for F in the unprimed frame. It occurs at t equals 0. So let's see, so this is going to be xf, tf. So tf occurs at 0, xf occurs at 8. Just reading the coordinates off of the graph in the unprimed frame. And I know that beta is 3/5. And gamma is 5/4. All right. So I want to know what t prime is. So I'll use the Lorentz transformation. T prime is gamma t minus beta x. All right, well, let's plug in. Gamma is 5/4. T is 0, that's convenient. So then I'm just going to have a minus beta. That's going to be a minus 3/5, and then x, which is 8. So that's 15/20 times 8. So let's see, 5 times 3 divided by 4 divided by 5 times 8 equals 6 with a minus sign. So this shows us that this time here is minus 6. So event F occurs 6 seconds before event B does, according to Beowulf. All right. So let me think about the same result another way. All right, so in Beowulf's frame, this is the scenario at event F, and then this is a scenario at event B. And I guess I should actually I shouldn't have moved the stick. It's actually the barn that's moving backwards, because in Beowulf's frame, Beowulf is at rest. All right, so the stick is 10 meters, and the barn, we decided, is 6.4. So this leftover distance here this is going to be 3.6. So then the question is, well, how long does it take the barn to move from here to here, to travel 3.6? And we can figure that out because we know how fast the barn is traveling. So let's do that. So delta x is beta delta t. So distance equals rate times time. And I want to know the time, and I know delta x. So I've got 3.6. Well, let me do this algebraically first. Let's divide by beta. And that's going to be delta t. And then delta x is 3.6. Beta is 3/5. And let's see what our calculator tells us for that. 3.6 divided by quantity, 3 divided by 5, n quantity equals, hey, that's 6. That's a familiar number. So both of these approaches, doing the translation using the Lorentz transformation, or using this, thinking about how fast the barn is moving relative to Beowulf, and so the time difference between this and this, they both give us 6 seconds. So that event F, the fronts align 6 seconds before the rears align. So let me end by summarizing. The apparent paradox is that in Anna's frame, she sees the pole for an instant completely enclosed by the barn. And in Beowulf's frame, the pole is 10 meters and the barn is 6.4 meters. So how can this be possible? And the answer is, as is often the case in relativity, that the non-intuitive part that makes this seem confusing at first is the assumption that time is universal, that time is just time, that time is not observer dependent. But as we know, that's not the case. In particular, what we're seeing here is that these two events, the front of the pole aligning with the barn and the back of the pole aligning with the back of the barn, are simultaneous in Anna's frame, but they aren't simultaneous in Beowulf's frame. So here's a cartoon that, or it's not a cartoon, a drawing that illustrates that. So this is what Anna sees. This is a barn. It's a brown structure with a pointy roof. And then this is the pole. And Anna sees at time t equals 0, the pole is inside the barn. Nothing controversial about that. Beowulf, in his world, is carrying a 10-meter pole and runs by a 6.4 meter barn, and that's not really a big deal either. He sees this initially at time t equals minus 6 seconds on the diagram. So the front of the pole aligns with the front of the barn, and 3.6 meters are sticking out to the left. Again, no big deal. You've got a 10-meter pole that's larger than a barn. And then 6 seconds later, this is the situation. So now actually in his frame, the barn is moving right to left. We could think about him moving left to right. Now the back of the pole aligns with the back of the barn. So this is not controversial. This is exactly what we'll expect Beowulf to see. This is exactly what we'll expect Anna to see. And the key is that these two events are simultaneous for Anna, but these two events are not simultaneous for Beowulf. Lastly, I should mention that I've been really sloppy with units all throughout this. So I've been calling these meters and then these seconds. In reality, I probably should have used nanoseconds for all of these units. That would have made a lot more sense. I don't think that doesn't change any of the math or any of the results, but all of these units should have been the same, and nanosecond probably is the most natural unit. I just didn't want to say nanosecond over and over again. All right, so that is the barn and pole paradox.